Rome from above. Looking for hotspots within the urban heat island with enhanced Landsat satellite data. Cities generally are warmer than its surroundings due to the way we build, the energy we use, and there are less trees and plants to provide cooling by evaporation. It is called the urban heat island effect. With a changing climate, heat will increasingly become an unpleasant factor for everyone in the city, and the number of heat-related deaths is expected to increase. The urban heat island effect looks like a problem that is too big to solve. But is it? First, we need to look at the temperatures within cities in far more detail to locate the hotspots. If we can change these radiators, we can in theory even make a city cooler than its surroundings. Software was written to improve the resolution of the Landsat data provided by the American USGS. First, we take the average summer temperatures for Rome as an example. It is clear the old center is heating up less than the more recently developed areas in the east. The National Library, Termini train station, and the Castro Pretorio barracks are visible as hotspots. Let's now locate the heat sources in Termini train station and of the hotspots in the northeast. We can see that the biggest problem is on the platforms where the trains are. What if we adopt the cool roofs idea? Painting the roofs of the building over the platforms and on the trains white. More of the sun's heat will be reflected. This will result in a better average temperature. Barracks and library are on the grounds of the Castra from the Praetorian Guard built by Tiberius. The Castra was built on an elevated area that was originally outside the city walls. A large part of the massive ancient wall is still there. The temperature peaks on the tarmac of the barracks. In Los Angeles, tarmac was painted, reducing the temperature by several degrees. Cool roads. Painting roofs and roads helps, but the height might also be a factor. In the next video, the west bank of the Tiber is just a little cooler, which might indicate more heat absorption by the ground. If the ground is a little lower than its surroundings, it will be closer to the groundwater and therefore more moist. Next, we focus on another hotspot, the school and barracks of the Carabinieri. The colors and boundary values can be optimized for each individual hotspot. Again, the dark tarmac is a problem. Trees and a small soccer field do not make much of a difference. What if one by one we focus on each hotspot, find out what all the relevant factors are, and change them? Next summer the effect will be visible in the Landsat satellite data. Getting rid of hotspots is probably the most efficient way to reduce the urban heat island effect in any city, resulting in reduced summer temperatures and better living conditions.